Welcome to A-Level and AP Physics. In today's lesson, we will discuss one very important question on circular motion from October-November 2021, paper 4, variant 1. I said this question is very important because this question will help you to improve your conceptual understanding of circular motion, and it will also challenge your understanding of circular motion. In today's class, we are talking about October-November 2021 paper 4-1, and total time for this exam is 2 hours and you need to answer all the questions. And total mark for this paper is 100. On the second page of exam paper, you can also find values of some constants, and these are very important because in your exam, maybe for some calculations, you will need them. So you can come back to second page and you can find values of constants. On third page, you can find some basic formulae. Let me highlight the one especially you need for A2 physics. The first one is about gravitational potential. With the help of this one, you can find potential at any point in gravitational field. But you can also use this one to calculate gravitational potential energy. Simply you need to multiply potential with mass. And next one is about ideal gas. You can calculate pressure with the help of this one, but you can also rearrange this one and you can calculate average translational kinetic energy of gas. Most of the time in exam they will ask you to derive translational kinetic energy of molecules. You will need this formula. So you have to start from this one to derive translational kinetic energy of molecules. Next one is about simple harmonic motion. It's very important one, and this is the basic formula. And every simple harmonic oscillator has to obey this equation. So this is very important. Simply I can say this is key formula for simple harmonic motion. Next one is about velocity of particle in simple harmonic motion. If you need to calculate velocity at any given time, you can use this one. But if you need to calculate velocity at any given displacement, you can use this one. X here is the displacement. So X here is the displacement. X naught is the amplitude and omega is angular frequency. And next one is about electric potential. This formula, also basic formula, you need this one for calculations in electric field, means calculations about electric field. If you need to find potential at any point in electric field, you can use this one. And next one is about capacitors in series. Very basic formula. You also need to understand how to derive this one. And the next one is about capacitors in parallel. You also need to understand how to derive this one as well. And the next one is about energy stored in a charged capacitor. Q is the charge on single plate of the capacitor, and V is the potential difference between plates. And next one is about Hall voltage. Very important one. Most of the time, if there is any question about Hall voltage, even they will ask you what is N, what is T, and what is Q. So you need to understand what is T, what is N. Next one is about alternating current or alternating voltage. So this is basic formula. If this is V, so this will be V naught. If this is I, this has to be I naught. So that's the reason they have written alternating voltage and current. Next one is about radioactive decay. And this is very basic formula. So let me highlight some points about this one. For example, you can use this relationship because this is telling you the relationship between X and T. And X can be number of nuclei at any given time. So then you can say this will be equal to N naught e to the power of minus lambda T. X also can be the activity at any given time. If you need to calculate, then this will be equal to A naught e to the power of negative lambda T. Even this one we can also use for discharging capacitor, means when the capacitor discharge. So simply I can write on here discharging capacitor. So when capacitor discharge, we can also use this one for current, for voltage, and also for charge. So when capacitor discharge, I is equal to I naught e to the power of minus T over tau. So tau is equal to RC. So you can also remember this one with the help of this relationship. And when capacitor discharge, V is also equal to V naught e to the power of minus t over RC, means this is tau is time constant. Q, we can also say this will be equal to Q naught initial charge times e to the power of negative t over RC. So understanding of this formula is very important. So all these formulae you can simply remember with this relationship. This is exponential decay, also exponential decays. And the last one is about decay constant. This is the half-life. So this is here is half-life. So if you have value of half-life, you can plug in here and you can find out decay constant. For part A, question is asking us to describe uniform circular motion with reference to velocity and acceleration. It simply means that we need to describe uniform circular motion using reference of velocity and acceleration, means simply using concept of velocity and acceleration. First of all, let's try to understand in a very simple way what is uniform circular motion, or simply we can say what is UCM. Uniform circular motion simply means that speed of object is constant, means when the body is doing circular motion, its speed does not change. So this is the simple idea, the main concept we have. Now let's try to understand this one with the help of velocity and acceleration. Let's say this is our circle and there is a one body that is doing circular motion, and the velocity of this body, let's say, is v. Now as the speed of this body is constant, it means it has no angular acceleration, it has no linear acceleration or tangential. So the resultant force in this case has to be pointing towards center. So let's say this is force F, and direction of acceleration always same as direction of resultant force. So this is direction of resultant acceleration, or we can say net acceleration, and this net acceleration in this case is centripetal acceleration. Now if you look at force and velocity, the angle between them is 90 degrees, and the angle between v and acceleration is also 90 degrees. Now we need to understand why the speed is not changing, as there is force acting on this one. The force is acting but the speed is not changing, so simply we need to understand the work done by this force. Work done by this force, we can say FD cosine of theta, and the angle between force and the displacement, that is 90 degrees. So this is FD cosine of 90 degrees, and cosine of 90 degrees, this is equal to 0. So the work done by force is equal to 0. If no work is done by the force on this body, it means there will be no change in kinetic energy of the particle, or we can simply say of object. As there is no work done by the force, it means there is no change in kinetic energy. So that's the reason speed stays constant, and that is only possible if velocity and acceleration, they are perpendicular to each other. Mean this net acceleration and this velocity, they are perpendicular to each other. We can say AC, I would say this is A net, not only AC. A net and velocity, they have to be perpendicular, and magnitude of velocity has to be constant. So the second thing we can say, then v is constant, the magnitude of v is constant, because this is uniform circular motion. So these 2 points simply we have to write down. If we write down these 2 points, we will get 2 marks. Now let me show you the answer. How you can write down answer means the points you need to write a good answer. So these are the 2 points you have to mention in your answer. The first one, if you have mentioned constant magnitude of velocity, means magnitude of velocity is not changing, you will get 1 mark, and this is B mark. And the second one, if you have mentioned acceleration always perpendicular to velocity, you will get 2nd mark. For part B, it is given to us 2 cars are moving around a horizontal circular track. One car is moving in circle X, means this is given X, and the other car is moving in circle Y. Radius of circle X is given, and that is equal to 318 meters. We can say this is Rx, so this is Rx. Radius of circle Y we can also find out, and that one will be equal to 27 plus 318 meters. It is also given to us mass of each car is 790 kilograms, means they have the same mass, and maximum sideways frictional force each car experienced, that is also the same. And the maximum speed for the car moving in circle X is given, and that is equal to 94 meters per second. And question is asking us to calculate F, means the force acting on car X, means the car moving in circle X. So we can simply imagine that this is car and this is moving in circle X. We need to find out the force acting on this one, means the frictional force that is acting sideways we need to find out, and this is F. This force we need to find out. Now as it is moving in a circle, it is doing circular motion, so this frictional force is responsible for circular motion. So simply in this case, frictional force is providing the centripetal force. So we can simply say F in this case is equal to mv square divided by r. Now value of V is given, value of R is given, M is given. Simply we can plug in and we can find out the value of F. Mass in this case is 790 kilograms, and the maximum force, we need to find the maximum value of F. So we have to consider the maximum speed. Maximum speed is 94. So this is 94 square divided by radius of the circle, as it is in this circle X, so the radius is 318. Now simply if we solve this one, our final answer will be 22,000 Newton. We can simply say 22 kN, or simply here we can write down this is 22,000 Newton, and this is the force. And this question has 2 marks, and the first mark is if you have used this formula, you will get 1 mark, and that is C1 mark. And the second mark is answer mark. If you have got the right answer, you will get second mark. For the second part, we need to compare centripetal acceleration of X with Y. We also need to compare the maximum speed of X with Y, and also we need to compare the time taken for one complete cycle of X with Y. So let's start first of all, what is the same for the car when it is moving in a circle X, and what is the same for the car which is moving in circle Y. In question it is given to us that the mass is the same, means these two cars, they have the same mass. So first thing we can write down, they have the same mass. It is also given to us they experience the same maximum frictional force. So the maximum sideways frictional force, that is also the same for X and also same for Y. Let's start from centripetal acceleration. First of all, we can simply say in this case F max, this is equal to the centripetal force, means centripetal force is provided by sideways frictional force, and this is equal to MAC. In this case, F max is the same for X and same for Y, and mass of these two cars is also the same, so it means AC is also the same for X and also for Y. So simply we can tick here, so same for X, same for Y. Now we need to compare the maximum speed. In order to compare maximum speed, we can simply rearrange this centripetal force equation in this way. We can say Fc is equal to mv square over r. But in this case, Fc is the same, means F max is the same, m is the same. Now if r is bigger, r is greater, it means v has to be greater. But in this case, ry, this is greater than Rx. So it means Vy has to be greater than Vx. So simply in this case, Vy is greater than Vx. So this is, we can tick here. The last one is about time taken. So for time taken, we can rearrange this one centripetal force equation. We can simply say this is mr omega square. We have to compare time. So omega, we cannot directly compare with omega. So we can write on this one in form of time. So we can rearrange. We can write on mr. Omega is equal to 2 pi over t. T is the time period. We have to compare time period. So it must be in our equation. So we can say this is 2 pi over t square. Now if you look at this equation again now, so this is Fc, this is the same, mass is the same, and 2 pi is the same. Now simply we left with r and t squared. So if r is bigger, so simply I can say in this case, let me write down in detail. Fc is constant, so we can write down here. M is constant, we can write down, we can divide by M here. And 4 pi, we can also divide this one by 4 pi square, so 4 pi square. So all these quantities are constant. So simply we left with R over T square. So this is constant. So these quantities are constant, so we can write down these quantities are constant. It simply means that the ratio of R over T square, this has to be constant. This ratio has to be constant. So simply we can say it has to be constant. Now if R is bigger, this quantity is bigger, time has to be greater to keep constant. The ratio between these two to keep constant, T has to be greater. So it means if Ry is greater than Rx, so the time taken to complete one cycle for Y, that will be greater than time taken by X. So Ty has to be greater than Tx. So we can simply tick here. And this question has 3 marks. So this has 1 mark. This is B1, means you have to tick here. And this one also has 1 B mark. You must tick in this circle. And the last one is also B1 mark. So if you tick in this rectangle, you will get this mark. That's all for this question. I hope it is clear to you. Simply you need to understand how to rearrange centripetal force equation to answer these questions. Welcome to A-Level and AP Physics. In today's lesson, we will discuss a typical type of question on gravitational field from October-November 2021 paper 4 variant 1. In this lesson, we will discuss what is gravitational potential. Actually, in physics, gravitational potential is not defined. Only gravitational potential difference is defined. So we will discuss how we can define gravitational potential at any given point. We will also discuss how to find the position of neutral point between moon and oval planet. At the end of this lesson, we will also discuss how to determine value of gravitational potential at neutral point between our planet and moon. So we're going to discuss some very good points about gravitational field in today's class. For part A, question is asking us to define gravitational potential. But gravitational potential is not defined in physics. What is defined in physics is gravitational potential difference. So in this lesson, first of all, we will understand what is gravitational potential difference, and then we will discuss how we can derive gravitational potential from gravitational potential difference formula. So first of all, let's try to understand what is gravitational potential difference. Imagine that we have 2 points. Let's say we have point A and here we have point B. You can also imagine that this is our planet. So these 2 points are in gravitational field. Now, if we place a unit mass at this point and its velocity, initial velocity is equal to 0, and we move this unit mass from point B to point A, when this reaches at point A, its velocity is again equal to 0. It simply means that in this case there is no change in kinetic energy of unit mass. So the amount of work done, that amount of work done is equal to the potential difference between A and B. We can also write on this one in this form. We can say VA minus VB, mean the potential difference between A and B. This is equal to the amount of work done from B to A per unit mass. So this is how we can define the potential difference between A and B. Now we need to understand how we can define gravitational potential. For that purpose, we have to take our point B at infinity. Now we will say point B is at infinity, and at infinity we can take potential is equal to 0. So infinity is our reference point. So this is our reference point. So this is our reference point, and at infinity V is equal to 0. So we will repeat the same process now. We will take unit mass from point B, means from infinity. So at infinity this mass was at rest. We take this one and move this mass very slowly and take this mass to point A. So this is our point A. So the amount of work done to bring this unit mass from infinity to point A, this is equal to the potential at point A. In this case, again, there is no change in kinetic energy. Now, if we write down VA minus VB, in this case, VB is at infinity. So we can say the work done to bring this unit mass from B, or we can say from infinity to A per unit mass. That amount of work done is equal to the potential at A, because V infinity is equal to 0. So simply we can say in this case VA, this is equal to the amount of work done to bring this mass, or we can say amount of work done per unit mass from infinity to A. This is equal to potential at point A. This is how we can define gravitational potential. But one thing we need to understand is that this is equal to the amount of work done per unit mass to bring mass from infinity to that point without change in kinetic energy of the mass. So this is how we can define gravitational potential. Now let me show you how you can write down your answer. And this is how you can write down your answer. This question has 2 marks. The first mark, if you have mentioned work done per unit mass, you will get 1 mark. And the second mark, if you have mentioned from infinity to that point, you will get second mark. So this question has 2 marks. And these are B marks, so they have to be in your answer. For part B, it is given to us P is a point, as you can see here. P is a point and it is located on the line joining the centers of our planet and moon, where the resultant gravitational field is equal to 0. And it is also given to us point P is at a distance x from the center of our planet. For this question, we need to explain how it is possible for the gravitational field to be 0. Even there are 2 large masses present nearby, means nearby this point. So we need to understand why value of G is equal to 0, means the resultant gravitational field at this point is equal to 0. So first of all, let's try to understand the gravitational field due to moon. So this is gravitational field due to moon and this will be pointing to the right. And now if you look at the gravitational field due to earth, so that will be pointing this way. If the resultant gravitational field at this point is equal to 0, that is only possible if GE, this is equal to GM. So then the resultant of these two will be equal to 0 because they are pointing in opposite directions. So they will apply opposite forces on any mass if we place at this point P. And this point P where G is equal to 0 means the net G is equal to 0, or simply you can say where the net force, gravitational force on any mass is equal to 0 on the line joining these two objects. That point is also called neutral point. Neutral point. It means if you place any mass at neutral point, that mass will not experience any gravitational force. And F net is only 0 if the field due to these two objects are equal in magnitude and opposite in direction. So that's all what we need to understand. Now let's try to write down answer for this question. This is how you can write down the answer. So simply you have to mention that gravitational field from our planet and from moon are in opposite directions at that point. That's the reason the resultant field is 0, because fields are equal in magnitudes at this point and they're pointing in opposite direction. So this question has 2 marks. So first mark, if you have mentioned about opposite directions, you will get 1 mark, and the second mark you will get if you have mentioned they are equal in magnitudes at that point. That's the reason the resultant field is 0. And this point is also called neutral point. So P is a neutral point. For the second part, we need to show that x is approximately equal to 3.5 times 10 to 8 meters. We need to find the value of x. But we have already discussed that at neutral point, the value of G due to Earth, this is equal to value of G due to moon. So at P, they have the same magnitude, but they are in opposite directions. If we need to calculate value of G, simply we can plug in. This is Gm, and this is mass of Earth divided by the distance from the center of Earth to this point. and that distance is x squared. So simply we can write down this is x squared. And for value of g due to moon at that point, we can also calculate that will be equal to g capital M, and this is M mass of the moon divided by the distance from the center of the moon to the neutral point. Let's say that distance is y. So simply we can say that distance means this distance is equal to y. So we can write on here this is y squared. Now you can see here g is common, so this is gravitational constant, universal gravitational constant, so simply we can cancel. So we left with mass of our planet divided by x square, and this is equal to mass of moon divided by y square. But y in this case, y simply in this case is equal to 3.84 times 10 to 8 minus x. So simply we can plug in value of y now. So the y is equal to, so this is value of y is equal to 3.84 times 10 to 8 minus x square. Now we need to plug in values. So the mass of Earth is given, so you can see the mass of our planet is given, and this is 5.98 times 10 to 24, and this is divided by x squared. And here we have the mass of the moon, so mass of moon is given. Mass of moon is equal to 7.35 times 10 to 22, and this is divided by 3.84 times 10 to 8 minus x squared. Now simply we have to find out the value of x. So we solve this one for x. You can simply cross multiply. So let me give you some hints. So you can cross multiply this one. So you can multiply here, cross multiply these two, and you can cross multiply this, and then you can solve for x. So the final value of x, if we solve this one for x, our final answer will be in this case 3.5 times 10 to 8 meters. So this will be our final answer for this question. And this question has 2 marks. The first mark is if you have included this step in your calculation, means you have equated GE and GM. And the final mark is answer mark. If you have got the right answer, you will get second mark. For the last part, question is asking us to calculate gravitational potential at point P, means the value of potential at this point, at this neutral point. We have to find out what is value of gravitational potential. If we need to find the gravitational potential at point P, so simply I will write down, let's say Vp. So that Vp will be equal to the potential due to our planet at that point plus potential due to moon at that point. So this is the main concept we need to understand. And now the next thing we need to understand, how we can find the potential due to our planet at this point. That will be equal to negative g mass of our planet divided by the distance from the center of our planet to that point, and that one is equal to x, plus potential due to moon at that point, that will be equal to negative g capital G and times mass of moon divided by distance from the center of moon to that point. As I mentioned before, let's say this distance is equal to y. So this will be divided by y. In this equation, for example, we can take negative g, we can take common. If we take common, then we simply left with this is mass of our Earth divided by x, plus we can say this is the mass of the moon divided by y. Now simply we need to plug in values and we can find out value of potential at this point. So let me highlight one point. Let's say we take this is our planet, and here let's say this point is infinity. At infinity we take potential is equal to 0. So anywhere from the center to this point, potential is always negative because this is the maximum value of V we have. So anywhere here between planet and infinity, V is negative. So that's the reason we are using the negative sign here, because potential between our planet and infinity is negative, because the maximum value of potential is at infinity, and that is equal to 0. So anywhere here it is negative. So that's the reason we are using negative sign here. Now we need to understand x we have already found. So let me write down values of x. X we have found that was equal to 3.5 times 10 to 8. And y, this will be equal to 3.84 times 10 to 8 minus x. Now you can write down the value of x. So we can say this is 10 to 8 minus x. Value of x is 3.5 times 10 to 8. So from here we can find out value of y, that will be equal to 0.38 times 10 to 8. So this is value of y. So you can see this is value of y. So we have found out value of y, we have value of x, we have mass of moon, we have mass of our planet. Now simply we need to plug in these values here. So value of g is 6.67 times 10 to negative 11 times the mass of earth, that is 5.98 times 10 to 24, and this is divided by x, and x is equal to 3.5 times 10 to 8 minus, we have the mass of the moon, and mass of the moon is 7.35 times 10 to 22 divided by the value of y, and value of y is 0.38 times 10 to 8. Now simply we need to solve this one, we need to calculate. If we do calculation, in this case our final answer will be negative 1.3 times 10 to 6, and this is joules per kg. So this is joules per kg. So this is how we need to answer this question, and this question has 3 marks. The first mark is if you have written for the moon, for example, we have written what is the gravitational potential of the moon. So if you have written this formula and you have plugged in values, you will get 1 mark, and this is C mark. And the second C mark you will get if you have written moon and our planet gravitational potential, means you have done this step. If you have done this step, you will get second C mark. So this is second C mark. And the third mark is the answer mark. If you have got the right answer, you will get third mark, and this is A mark. This is how marks will be awarded for this question. I hope it is clear to you. If you have any questions about calculations or any other question, just leave your questions in comments section. That's all for this video. Welcome to A-Level and AP Physics. In today's lesson, we will discuss one important past paper question on thermal physics from October-November 2021, paper 4, variant 1. I said this question is very important because we will cover some very important concepts about thermal physics in today's lesson. And those concepts are most frequently asked in past papers.
For part A, we need to define specific heat capacity. First of all, let's try to understand what is specific heat capacity. Imagine that we have unit mass of any substance. When we talk about unit mass, it simply means that we are talking about 1 kg in SI units. So unit mass in SI units simply means that 1 kg. Now imagine that if we place thermometer inside this mass, so inside this substance, and let's say the temperature of this substance, the initial temperature is 20 degrees Celsius. We want to raise this temperature by 1 degree Celsius. In order to raise this temperature by 1 degree Celsius or by 1 Kelvin, the amount of thermal energy we need to supply, that amount of thermal energy is called specific heat capacity. So this is what exactly is meant by specific heat capacity. When we talk about change in temperature, so you can say to raise temperature by 1 Kelvin. You can also say to raise temperature by 1 degree Celsius, because change in temperature in Kelvin is the same as change in temperature in degree Celsius. So we can say the amount of thermal energy required to raise temperature of substance of unit mass by 1 degree Kelvin or by 1 degree Celsius, because the change in temperature in degree Celsius is equal to change in temperature in Kelvin. Now let me show you how you can write down a proper answer. So this is how you can write down a proper answer. This question has 2 marks. If you have mentioned amount of thermal energy required, you will get 1 mark, and this is B mark. And the second mark you will get if you have mentioned about change of temperature of unit mass by 1 Kelvin or by 1 degree Celsius, you will get second mark. And this question has 2 marks. For part B, one question is asking us to state an expression in terms of V, N, P and Boltzmann constant K for thermodynamic temperature of the gas. So this is quite straightforward one. PV is equal to NKT. We need to write down expression in terms of PV, N and K for temperature. So simply we can say in this case T is equal to PV over NK. So this is what we need to write down, and this question has 1 mark. So if you have written this one, you will get 1 mark, and this is B mark, means it has to be in your answer, means your answer has to be in this form. For the second part, we need to show that kinetic energy of a molecule is given by this expression. So we can simply start this one from PV is equal to 1/3 Nm c square. So this is mean square speed, and m here is mass of single molecule. So this one we can write down mass of one molecule. So this is mass of one molecule. So you have to be very clear about this. We are talking about kinetic energy of a molecule, mean single molecule. N is the total number of molecules. So simply we can say N is number of molecules in the gas. So this is number of molecules in a sample. Now we need to prove that Ek is equal to 3/2 kT. But we have also said that PV is equal to NKT in part 1. Now simply we need to equate these two. We can say this is 1 and this is second equation. We need to equate these two to find this expression. So now simply we can say that 1/3 Nm mean square speed, this is equal to NKT. But N is common on both sides, so simply we can cancel N with N. We can also multiply this side with 3, so we also have to multiply this one by 3. So this one we can cancel here, so we left with mc square, means mass of molecule time mean square speed, and this is equal to 3 kT. Now if we divide both sides by 2, so simply we can say that this is kinetic energy of a molecule. So this is translational kinetic energy of a molecule. So simply we can replace this with Ek. So Ek is equal to 3/2 kT. So this is our final answer, and this is what question was asking us to derive, and this is our final answer. But one thing you need to understand is that when you calculate translational kinetic energy of a molecule, temperature has to be in Kelvin. So you have to use unit Kelvin for temperature if you need to calculate kinetic energy of any molecule. So that's all what we have to do for this question. And this question has 2 marks. The first mark you will get if you use this expression. So this is M mark. So you have to use this expression. And the second mark is answer mark. You will get if you got the right answer. For this question, we need to explain why the internal energy of the gas is equal to total kinetic energy of the molecules. Internal energy of any gas, this is equal to sum of kinetic energies of molecules. Internal energy is equal to sum of kinetic energies of molecules plus potential energies of molecules. That in case of ideal gases, there are no attractive forces between molecules. As there are no attractive forces between molecules, it simply means that there is no potential energy of molecules. So simply we can say the molecules, they do not have potential energy. So in this case, internal energy is only equal to kinetic energy of molecules. Internal energy is only equal to kinetic energy of molecules. So that's all what we have to write down. The first mark you will get in this case, if you have written no attractive forces between gas molecules, you will get 1 mark, and the second mark you will get if you have mentioned that potential energy of gas molecules is equal to 0. So you will get 2 marks. Now let me show you how you can write down this answer. So this is how you can write down the answer. So first mark is no forces between gas molecules, 1 mark. Second mark, no potential energy of gas molecules. And so these are 2 B marks. So you have to mention these 2 points in your answer. For part C, it is given to us the gas in B is supplied with thermal energy Q. We need to explain with reference to first law of thermodynamics why the increase in internal energy of the gas is equal to Q. First of all, we need to understand the increase in internal energy means the change in internal energy. This is equal to Q plus work done on gas. So this is the work done on gas. But work done on gas or work done by gas, this is equal to P times delta V. If there is no change in volume, it means no work is done on gas or no work is done by gas. But in this case, in part B, it was given to us that container is sealed. That was given to us in part B. Container is sealed. It simply means that the volume of the container will not change. Container is sealed simply means delta V is equal to 0. So if delta V is equal to 0, it means that W is also equal to 0. So work done by gas is equal to 0. Work done on gas also 0. So here we can simply say that delta U in this case is equal to Q. So the increase in internal energy is only due to thermal energy, or simply you can say change in internal energy is equal to Q. So 2 points we have to mention for this one. This question has 2 marks. The first mark we have to say is that delta U is equal to Q plus W work done on gas, you will get 1 mark. Then the second mark you will get if you have mentioned that container is sealed, so work done is equal to 0. So you will get the second mark. Quite straightforward question. Let me show you the answer. This is how you can write down your answer in a proper way. So we can say increase in internal energy, or simply you can say this one is delta U, the change in internal energy, is equal to Q plus work done, and this is the work done on gas in fact. So this is work done on gas. So if you have written this point, you will get 1 mark. You can write down this equation as well. If you write down this one, you will get 1 mark. So this is over B 1 mark. And the second mark, if we have mentioned that container is sealed, or you can say volume is constant, so no work done, you will get second B mark. For the second part, question is asking us to use expression in part B2 and also the information from part C1 to show that specific heat capacity C of the gas is given by this expression. Simply means that we have to derive this one. If we go back to part B2, in part B2 we have discussed that kinetic energy of a single molecule, this is equal to 3 by 2 kT, and this is kinetic energy of single molecule. That if we are talking about kinetic energy of a gas, total kinetic energy of a gas, so we have to multiply this one with number of molecules, means total kinetic energy will be equal to sum of kinetic energies of all the molecules. So we will say total kinetic energy or internal energy, that will be equal to 3 by 2 nkt. If we are talking about the change in kinetic energy, so we can rewrite this one. We can say this is 3 by 2 nk times change in temperature. But for ideal gases, we also understand that delta U mean the change in internal energy. This is equal to change in kinetic energy. So simply we can say the change in internal energy, this is equal to nk times delta T. In part C1 we have discussed that delta U is equal to Q. Now we have to use these informations to derive this formula. So first of all, we will start from Q is equal to mass of the gas times C times delta T. M is the mass of the gas. That mass of the gas we have to write down in this form, means capital M is equal to N times small m, because in the final expression we need mass of single molecule. So capital M we will replace with number of molecules times mass of single molecule. So we can say NMC delta T. But Q is equal to delta U. In part C1 we have discussed. So we can say Q is equal to delta U and this is equal to MC delta T. But delta U is equal to delta EK. So we can say delta U, this is equal to delta EK, means increase in kinetic energy, and this is equal to 3 by 2 NK delta T. Now we can write down this is equal to NMC delta T, and now simply we have to further simplify this. So you can see N is common, we can cancel with N, and in this case delta T is common on both sides, we can cancel this. So we simply left with C is equal to 3 by 2K, and here we have mass, so we will divide this one by M. Simply we can say this is equal to 3K divided by 2M. So this is specific heat capacity of gas in terms of mass of single molecule and Boltzmann constant. So this is how we can derive. This question has 2 marks, and the first mark is if we have written this expression, we will get first mark, and this is C mark. And the second mark is if you have got this right answer, and this is answer mark. For part D, it is given to us that gas is able to expand now because the volume of new container is not fixed, and we need to suggest with a reason how the specific heat capacity of the gas would compare with value in C2. For this purpose, let's start from here. Let's say for case 1, we had a container that has a fixed volume. So this container has fixed volume. So this is our case 1. In this case, to increase the internal energy, we have said that Q was only equal to delta U. Mean all the thermal energy was used to increase internal energy of the gas. But now in second case, we can write down, let's say we have this cylinder. So simply you can imagine that this cylinder, inside this cylinder we have gas, and this cylinder has not fixed volume, means the volume of this cylinder can change now. So the volume of gas is not fixed. So when we heat up this one, we give certain amount of heat Q to this one, this gas will expand. So in this case, work is done by gas. So we can say the Q, this will be equal to change in internal energy plus work done by gas. So internal energy, this is directly linked with change in temperature. So we have discussed before, delta U is equal to 3 by 2 K times delta T. Now in order to increase the same temperature, we have to give more Q, because in this case gas is also doing work, means gas will do work against atmosphere, because it is given to us the pressure remains constant. So P remains constant in this case, pressure of the gas, and that will be equal to the atmosphere. So this will go on expanding. So this gas will go on expanding. So this Q, actually, if we want the same rise in temperature, Q has to be greater by this amount. So Q has to be greater by this amount. Now if we write down the formula for specific heat capacity, that is equal to Q over M times delta T. So for the same rise in temperature, this Q has to be greater, because this Q is equal to delta U plus the work done by gas. So this is equal to work done by gas. So simply you can divide this one by M times delta T. M is the mass of the gas. So this Q has to be greater. So if Q is greater, it simply means that C is greater, and in this case C is simply equal to Q over M times delta T, and Q is equal to only delta U. So that's the reason the C in this case will be smaller, this will be lower because this Q is lower, so the new value of C will be greater. So that's all what you need to understand. These points you have to understand. If you have understanding of these points, now we can write down our final answer. And this question has 2 marks, so let me explain to you how to write the answer and how marks will be awarded. First mark will be awarded if you will say, as gas expand, gas will do work against atmosphere. So in this case you can see when the gas is expanding, gas has to do work against atmosphere. So because there is P atmosphere that is acting on the gas, so in order for gas to expand, it has to do work against atmosphere. So you will get 1 mark. For same temperature rise, more thermal energy will be required because for the same rise in temperature you have to give more energy, because the extra energy will be equal to work done by gas. So if Q is greater, so it means C is greater, as you can see here. So larger specific heat capacity. So you will get the second mark.
Welcome to A-Level and AP Physics. In today's lesson, we will discuss a typical type of question on simple harmonic motion from October November 2021, paper 4, variant 1. In this lesson, we will discuss how to calculate angular frequency of oscillations and how to calculate maximum speed of oscillating body. We will also discuss how to deduce information about oscillating body when displacement against time graph is given to us. At the end of this lesson, we will discuss how to sketch velocity against displacement graph for simple harmonic motion. For question number 4, it is given to us a trolley on a track is attached by springs to fixed blocks X and Y as shown in figure 4.1. As you can see here in this figure 4.1, we have one fixed block Y. This one is fixed block, meaning it cannot move. We have another block X. This is also fixed block. This block also cannot move, and the trolley is oscillating between these two fixed blocks, and trolley is attached to these blocks by springs. So these are 2 springs. It is also given to us track contains many small holes and air is coming out of these holes vertically. So air is coming out vertically upwards, and this air will reduce the direct contact with the track, or simply we can say air will reduce friction between trolley and ground. It is also given to us the trolley is pulled to one side of its equilibrium position and then released. So it oscillates initially with simple harmonic motion. After a short time, air blower is switched off. Variation with time t of the distance L. So here is the distance L of the trolley from block X is shown in figure 4.2. So this is figure 4.2. From this figure, we can also see at the beginning, you see this motion is undamped. So you can see this motion is undamped. So until this point, we have air blower on, mean air is coming out of the holes, and after that we switch off air blower. So you see damping start after that. So this is the damping. So you need to get the basic idea about this question. So the main purpose of reading question and explaining a little bit about graph is to give you the main picture of this question. I hope now you have clear picture. We can go to next and we can answer question. For question A1, we need to determine the initial amplitude of the oscillations. But if we look at this graph, we can simply find out when L is equal to 20 centimeters, trolley is at equilibrium. So we can also draw this line. So you can draw this horizontal line, we can now see very clearly that this is the equilibrium position when L is equal to 20 centimeters. So the maximum displacement of this trolley from equilibrium is 5. 25 minus 20, so that is 5. So it's better to write down 5.0 centimeters. So this is initial amplitude of oscillation. This question has only one mark, and that is answer mark. If you have written 5.0, you will get this 1 mark. For our second part, we need to calculate angular frequency of oscillations, and angular frequency is equal to 2 pi over capital T. Capital T is the time taken to cover 2 pi radians angular displacement. 2 pi radians angular displacement simply means one cycle, or we can say one oscillation. So this time is the time period. So simply we can write down capital T here. This is the time period. Now, if we have value of time period, we can calculate angular frequency. So if you look at figure 4.2, we can find out that this is one complete oscillation. So this time taken is equal to time period. Now, simply we can plug in value of capital T here. Capital T is equal to 4. And we can cancel this 2 with 4, so simply we left with pi by 2, and pi by 2 is equal to 1.6 radians per second. So our final answer is 1.6 radians per second. This question has 2 marks. The first mark you will get if you have written the right formula, means you have written this formula, you will get first mark, and that is C mark. You will get 1 mark. And the second mark you will get if you have got the right answer. If you have got the right answer, you will get in fact 2 marks for this question. But if your answer is wrong, you have written this formula, still you will get 1 mark. For the next part, we need to calculate the maximum speed of the oscillating trolley, but our answer has to be in centimeters per second. Maximum speed, first of all, let me explain to you how you can calculate. Vmax is simply equal to A times omega. A is the amplitude. If you multiply this one with angular frequency, we can find Vmax. A we have already calculated in part A1, that was equal to 5.0 centimeters. And value of omega we have calculated here, but this value is up to 2SF. This is not the exact value of pi by 2. If I divide pi by 2, the exact value will be 1.57. So in next calculation, we will use the exact value. So I'll be using here omega is equal to 1.57 because this is approximately equal to 1.6, mean up to 2SF. So that's the reason we have written here 1.6. This is correct answer. Now we are using exact value of omega here. Now if you do this calculation up to 2SF, our final answer will be 7.9 centimeters per second. It's better to use the exact values in the next calculations. So this is a good way, this is a good science. So always try to use exact values in the next calculations. And so our final answer is 7.9 centimeters per second. And this question has 2 marks. The first mark is if you have used this formula. If you have written this one, you will get 1 mark. And that is C1 mark. And the second mark is answer mark. If you have got the right answer, you will get 2 marks. But if your answer is wrong, you have written this one, you will get 1 mark. So always start by writing formula and then plug in numbers and then do calculations. Let's try to understand how we got this formula. Means how do we know that Vmax is equal to A times omega? In the formula list, you can find out V as a function of X. This is equal to plus minus omega times A square minus X square, and this is given in formula list. On third page you can find out this formula. Now if you need to find Vmax, means you need to find out Vmax, and V is maximum at X is equal to 0, means at equilibrium position the speed is maximum. Now simply from here we can find out, means V at X is equal to 0. This will be equal to plus minus omega, and X is 0 in this case. So we can say A square minus 0 square. From here, we can simply write down Vmax. This will be equal to A times omega. So this is how we got this one. Vmax is equal to A times omega. You no need to worry about plus minus sign. We are talking about speed here. So we no need to worry about plus minus. So this is how we got this formula. For part B, we need to describe what may be deduced from figure 4.2 about the motion of the trolley between time t is equal to 0 to t is equal to 24 seconds. Means when time is equal to 0 to time is equal to 24 seconds. In this interval of time, we have to describe the motion of the trolley using this graph. And it is also given to us no calculations are required. And we no need to include the quantities we have already discussed in part A. And this question has 3 marks. It means at least 3 points we have to write down to get 3 marks. So first of all, let's start from here. So you can see here, first of all, displacement is positive. So this displacement is positive. And by convention, we take to the right is positive. You see L is increasing and this is positive. It means the trolley is pulled to the right. So simply first part we can say trolley is initially pulled to the right. So this is can be our 1 point. It is pulled to the right initially. So this is 1 point we can write down. And the second point we can write down period of oscillations. This is equal to 4 seconds. So this can be the second point. We can say the period of oscillations. This is equal to 4 seconds. So this can be the second point. Now, if you look at amplitude of oscillations, we can simply see that until t is equal to 12 seconds, amplitude of oscillations is constant. So this motion is undamped. So we can say initially motion is undamped until here, but after that amplitude is decreasing. So this is damped motion, or you can say oscillations are damped. But if you look at amplitude, how it is decreasing, this is decreasing gradually, means exponentially this is decreasing. Then this kind of damping is light damping. So we can say this is light damping. So this can be our third point, and this one can be fourth point. That we can also talk about maximum speed. So this is the equilibrium position. So this here time is equal to 1 second. So the speed will be maximum. Here time will be equal to 3 seconds. Speed here will be maximum. Speed here is maximum. Speed here is maximum. So we can say the speed is maximum. We can write down V max at t is equal to 1 second. You can also say t is equal to 3 seconds. From this graph, we can also find out when the trolley speed is equal to 0. The speed of the trolley will be equal to 0 when its displacement is maximum, means at this point its displacement is maximum, so trolley will be stationary. At this point trolley will be stationary. At this point trolley will be stationary. At this point trolley will be stationary. So simply we can say trolley will be stationary when t is equal to 2 seconds, mean I'm talking about this point. Initially it started from rest, so initially at rest, you can also mention about that point. We can also say trolley is stationary when t is equal to 4 seconds, mean at this point. Even you can also say trolley was stationary at t is equal to 0, and so on. So you can see we can deduce about 6 points about motion of the trolley from this graph. And question is asking us to write down only 3 points. If you write down any 3 of these points, you will get 3 marks. Now let me show you how we can write down a proper answer for this question. For this question, you can write down these points. So you can see the first point I have written here means the trolley is pulled to the right. You will get 1 mark. Second mark, you can say period of oscillations is 4 seconds. You will get 2nd mark. And the 3rd mark, you can say initially motion is undamped, as we have discussed here. Motion is undamped until this point. Maximum speed is at t is equal to 1 second, means the speed is maximum here, speed is maximum here, and the trolley is stationary at this point, at this point, at this point. Means t is equal to 2 seconds, 4 seconds, even 0 second, you can say, as we have discussed here this part. Damping is like we have discussed here. So you can write down any 3 points, you will get 3 marks. And each mark is P mark, means this has to be in your answer. You can include any 3 points from here. For part C on figure 4.3, we need to sketch the variation with L of the velocity V of the trolley for its first complete oscillation. First complete oscillation, so this one is the first complete oscillation. So you can see from here, in this case, the speed of the trolley is maximum at this point. So speed of the trolley is maximum at equilibrium, and at this point speed of the trolley is also maximum. So simply we can say V is maximum, and the maximum value of V we have already calculated, that was equal to 7.9 centimeters per second, and this is maximum at L is equal to 20 centimeters. We can also see from here the V is equal to 0 at this point, means when L is equal to 15, so V is equal to 0 centimeters per second. We can say at L is equal to 15 centimeters, and this is also equal to 0 at this point. Initially it is 0, so we can say L is equal to 25 centimeters. And again, when it will complete cycle, L is again equal to 25 centimeters, so V is again equal to 0. Now simply we have to use this informations and we can sketch the graph. First of all, look at when V is equal to 0. So V is equal to 0 when L is equal to 25 centimeters. Mean at this point V is equal to 0. And V is equal to 0 at this point as well. V is maximum when L is equal to 20 centimeters. So here 20 centimeters. And the value of the V is 7.9. So this point is 5 here, so this one will be 6, this will be 7, so here will be 7.9, so 7.9 about at this point. So we can also find out V when it is maximum here, so this will be 6, here is 7, so here is 8, means 7.9 about here. Now we need to join this point, and the shape of this graph will be elliptical because V is equal to plus minus omega times a square minus x squared. So the shape is going to be elliptical. So simply we can say in this case shape of the graph will be elliptical. So we just need to join these points. Now let me show you how you can sketch this graph in a proper way. So this is how I have sketched this one, and you can see this is a proper shape of this graph. So this is how you need to sketch. Welcome to A-Level and AP Physics. In today's lesson, we will discuss one very important past paper question on capacitance from October-November 2021, paper 4, variant 1. I said this question is very important because in this question, we will discuss some very important concepts about capacitance. For part A, it is given to us the capacitance C is inversely proportional to X. And X is the distance between plates, and this distance is variable distance. It simply means that the distance between plates can be increased or it can be decreased. It is also given to us the capacitor is charged by a power supply, and there is a potential difference V between the plates. And question is asking us to state expressions in terms of C and V for the charge Q on one of the plates and for the energy E stored in the capacitor. It simply means that we need to write down expressions for Q and E, but our expressions have to be in terms of C and V. As this question is asking us to write down expressions for Q and E, so for Q, we can write down Q is equal to CV. And for E, we can write down this is equal to 1/2 CV square. So this is what you need to write down for this question. Now let's try to understand what's the meaning of Q is equal to CV. Q is equal to CV means if the capacitance of this capacitor is equal to C and the potential difference between the plates of capacitor is equal to V, means the potential difference between these two plates, if this is equal to V, CV, then the charge stored on these plates will be equal to Q. Means the charge stored on one plate, this will be equal to plus Q, and this is the magnitude of this charge, that is equal to CV. Means the magnitude of this charge is equal to CV. And there also will be charge stored on the other plate, and that will be negative Q. These two charges, they are equal in magnitude but opposite in polarity. So they have opposite sign but they have the same magnitude. So when we write down Q is equal to CV, it means we are talking about the charge on one plate. Means the magnitude of charge on one plate. So this is very important point. You have to be very clear. If we talk about the net charge on these two plates, net charge on these two plates, this is equal to 0. So when we write this formula Q is equal to CV, we talk about charge on one plate. And also you need to understand, capacitor is not used to store charge, because if you look at the net charge on these two plates, that is equal to 0. Capacitor stores energy, it does not store charge. So by separating charge, we store energy in a capacitor. So if you write down these 2 points, you will get 1 mark, and that is B1 mark. If you have written these two, you will get 1 mark, and that is B mark. Means it has to be in your answer. For part B, it is given to us the charge capacitor in A is now disconnected from the power supply. The plates of the capacitor are initially separated by distance L. This was the initial distance between the plates. Now plates are moved close together by a distance capital D as shown in figure 6.2. Plates are moved by distance capital D. Mean initially this plate was here, now it has been moved to new position. So this is the new position of the plate. Question is asking us to state expressions in terms of C, V, L and D for the new capacitance. Capacitance of a capacitor, actually it depends on area of the plates and permittivity of space between the plates. So simply we can say this is equal to K epsilon naught A over D, and D is the separation between plates. So simply this is the distance between plates, and A is the area of the plate. So area of one plate. So this is area of the plate. Epsilon naught, this is permittivity of free space. Means capacitance also depends on the medium between plates. So this is permittivity of free space, or AF we can also say, because these two media, they have very close permittivity. The permittivities are very close to each other, so we can also say permittivity of air. K is dielectric constant. So this is dielectric constant. The value of K for air or free space, that is equal to 1. So dielectric constant. So K is dielectric constant, and for air K is equal to 1. So for A simply we can write down C is equal to epsilon naught A over D. But in this case we need to understand what we are changing now. We are only changing the distance. If the distance decrease between plates, it means C will increase, and this is also given in the question. In part A it was given C is inversely proportional to X. So in question they have used epsilon naught A over X. Means X and C, they are inversely proportional. If X decrease, it means C will increase. Now if you look at this equation now, so simply we can write down in this case Cx, this is equal to constant, because epsilon means the media between these two plates, that is constant. So epsilon naught is constant, and area of the plates is also constant. So simply we can say Cx is equal to constant, and so this is equal to constant. Now we need to find out the new capacitance. So we can also say that Cn means the new capacitance times the distance between the plates, and the distance between the plates we can simply say that is Ln, the new distance, new value of L, that has to be equal to the initial capacitance of the capacitor, that is C, times L. L was the distance between plates initially as it is given, and we need to find out Cn. So we can simply rearrange. We can say Cn in this case will be equal to Cl divided by L. And L in this case, this is the Ln, means the new distance between plates, we are talking about this one, and this is ln. And this ln is equal to L minus D. So simply we can write down here L minus D. So this is the new capacitance. Simply you can see from here now, as this number is small, it means this one is bigger. So let me write down in a different way so you can understand. As you see, this goes down, ln goes down, so Cn go higher. Now this simply we can say in this case, Cn is greater than C. So the capacitance of the capacitor has been increased, and this is our answer for this part. If you have written this one, you will get 1 mark, and that is B1 mark. For the second part, we need to find the new charge Qn on one of the plates. But it is given to us the capacitor has been disconnected. It simply means that the power supply has been removed. So simply we can sketch this one so you can see what is happening. Now we have removed this power supply. If we imagine that there is a charge on this plate, let's say this was positive charge on this plate, there will be negative charge on the other plate. Now when we disconnect this battery, this charge cannot go anywhere. It has nowhere to go because this is like an open circuit. So it simply means that in this case, the charge on the plates, this will stay same. So we will say simply Qn will be equal to Q, and Q is the initial charge on the plates. And that one we have calculated, that one was equal to CV. So in this case, Qn is also equal to CV. So that's all what we need to write down. And this question has only 1 mark, and that is P mark. If you simply write down Qn is equal to CV, you will get this mark. For the next part, question is asking us to calculate new PD between the plates, means new value of V between the plates. We can simply start from Q is equal to CV. If we rearrange this one, we can write down V is equal to Q over C. We need new value of PD between the plates, so we have to use the new value of Q, means the new value of charge on plates, and the new value of capacitance. Qn we have already calculated, that is equal to Q. And the Cn we have already calculated in part A, and Cn was equal to Cl divided by L minus D. L minus D. Now we can rearrange this one. We can write down here we have Q times L minus D, and this is divided by CL. But Q is equal to CV, so we can replace Q with CV. Q is equal to CV, so we can write down Q is equal to CV times L minus D, and this is divided by CL. So we can cancel C with C, so we left with V times L minus D divided by L, and this is new value of Vn. So you can see here in this case Vn has been decreased. So the new value of V, this is less than initial value of V. So Vn is lower than V in this case. And that's all what we have to write down for this question. So if we simply write down Vn is equal to V times L minus D divided by L, we will get 1 mark, and this is B mark. For part C, question is asking us to explain, is the energy stored in the capacitor, it has been increased or it has been decreased due to reduction in the separation between the plates. First of all, let's try to answer this one using equation, means with the help of formula. So energy stored in a capacitor is simply this is equal to 1/2 QV, and this formula simply we can get, if we get Q against V, Q is the charge stored on the capacitor, means charge stored on single plate, and V is the potential difference between plates. So we will get this graph straight line, and the area under this one, this is the energy stored in a capacitor. So simply we can say E is equal to 1/2 QV. In this case, Q stays same because capacitor is disconnected from the power supply and charge has nowhere to go, so charge stays same. But V, we have seen that the new value of V, it decreases. So it simply means energy stored in the capacitor decreases when we increase the separation, when we decrease the separation between between plates. When we decrease separation between plates, energy stored in the capacitor decreases. We can also understand this one with the help of E is equal to 1 half Q square C. Q square divided by C. As Q stays same, but C increases. So when C increases, it means E decreases. We can also understand this one with the help of 1 half C V square. C V square. C in this case increases. So C increases, but V decreases. So overall E decreases. We can prove this one by using new values of C, means we have calculated new value of Cn. We also have new value of Vn. If we plug in these new values, then we compare with 1 half Cv square, can prove that energy will decrease. So this is how we can do with the help of these formulas. Now let's try to understand this one theoretically. So theoretically, it simply means that if we have, let's say this is our ground and we place one mass on the ground. If we raise this mass, let's say we raise this mass to certain height, let's say to this point, and h is the distance from center of mass when the mass is here to center of mass when the mass is at certain height h. So in this case, if we take this mass away from the earth, so this is our ground, simply you can understand this is earth, or you can imagine that this is ground. As the distance between these two increases, the gravitational potential energy stored in this object that increases, and this is also true for electrical potential energy. So in this case, if you look at this one now, when we move this mass up, so we have to do work against gravitational field. So the increase in gravitational potential energy, this is equal to the work done by external agent. So otherwise we can also express this one in terms of potential, means gravitational potential V, this will be equal to the work done by external agent, I will say by EXT, by external agent per mass. If work done by external agent, this is positive, it means the change in potential, this is positive. So the change in GPE, that is positive, or simply we can say if the work done by external agent is positive, GPE increases. So I will write down simply here, work done by external agent, if this is positive, GPE increases. So gravitational potential energy increases. In this case, we have to apply force up to lift this mass. So the work done by this force, means by external agent, this force is applied by external agent. It can be you, it can be a machine. So work done is positive, so the potential energy of this mass will increase. And this is also true for electrical potential energy. So imagine that this plate is negative plate. So simply we can say this is negative plate and this plate is positive plate. So this is positive plate. Now if we move this positive plate this way, the work done by external agent, that work done is positive. So in this case, the electrical potential energy, it has to increase. So if we move this one away, simply we can say in this case electrical potential energy, that will increase because work done by external agent, that is positive. So electrical potential energy will increase because there is a force acting on this plate this way, that is the electric force. E, we can say Fe, that is the electric force, and we apply force this way, means the external agent is applying force this way, and the plate is also moving in direction of force. So the work done by external agent is positive, and that work done by person or machine, any agent, that will be stored in capacitor in form of electrical potential energy. So that will increase the potential energy of this capacitor if this is disconnected. So we are talking about disconnected capacitor. This is also true if we bring this together, means if we move this positive plate this way. In this case, the work done by external agent against external agent has to apply force this way. to move this plate from here to somewhere here, that it has to keep the kinetic energy of this plate constant. Means there should not be any change in the speed of the plate when it moves from here. Means we have to move very slowly. So if you move this one from here to here, we have to apply force to the right, but the plate is moving to the left. So in this case, EPE will decrease because work done in this case by external agent, that is negative. So that's the reason EPE will decrease. Simply it means that energy is taken away. So that's all what we need to understand. Now let's try to understand this one in a very simple way. We will use concept of forces. F is the attractive force. If attractive force decreases, as you can see, the attractive force between mass, when the mass is here and when the mass is here, the attractive force between the ground and the mass decreases. So potential energy, I will simply say potential energy in this case, potential energy increases. And if the attractive force between mass and the ground it increase, means when the mass is somewhere here nearby ground, the attractive force will increase. So when this attractive force increases, PE increases, means the potential energy decreases. And this is also true for electrical forces as well. So when we move these plates together, attractive force increases. So when we move these plates together, attractive force between plates increases. So it means the electrical potential energy stored in the capacitor decreases. And that's all. This one point simply you need to write down for this question to answer this question. We can write down this one. We can also answer this using this equation. So anyone you can use, you will get 1 mark. Now let me show you the answer, what you need to write down. So this is how you can write down the answer, and this is also actually given in the mark scheme. If you write down opposite charge plates, they attract each other, so the energy stored decreases. As we have seen here, when the attractive force between the plates increases, between charged plates increases, electrical potential energy decreases. And this question has only 1 mark. P mark. If you write down this point, you will get. Even you can also write down, you can simply say that energy decreases because Q stays same and V decreases. So that's the reason energy stored in the capacitor decreases when the plates are moved closer. Welcome to A-Level and AP Physics. In today's lesson, we will discuss one very important past paper question on motor effect and electromagnetism. This question is from October-November 2021, paper 4, variant 1. In this lesson, we will discuss how to define Tesla in a proper way. We will also discuss how to find direction of force and magnitude of force on a current-carrying conductor inside uniform magnetic field. At the end of the lesson, we will discuss one very important concept about torque experienced by a loop inside uniform magnetic field. For part A, we need to define Tesla. So what is Tesla? Tesla is unit of magnetic flux density. Simply we can say unit of D means unit of magnetic flux density is Tesla. And the symbol we use for Tesla is capital T because this is after name of scientist. So we use capital T for Tesla. Now let's try to understand how we can define Tesla. Imagine that we have a uniform magnetic field. So this is uniform magnetic field. And inside this uniform magnetic field, we place a wire. So let's say this one is the wire we place inside uniform magnetic field. And there is current in this wire. If the length of this wire, let's say from here to here, means the length of the wire inside magnetic field, let's say this length of the wire inside magnetic field. So I will simply say L inside magnetic field, if this is equal to 1 meter, and current in the wire means I in the wire, if I in the wire is equal to 1 ampere. Then we can define magnetic flux density. So first of all, let's try to understand the formula for magnetic force. Magnetic force F is equal to BIL sine of theta, and theta is the angle between B and I. So this is the angle between B and I. Now, if the angle between these two is 90 degrees, so simply we can say F is equal to BIL, because sine 90 is equal to 1. Angle between B and I in this case is 90 degrees, so sine of 90 is equal to 1. So we can also write down here sine of 90 is equal to 1. Now we need to define B. So we can rearrange this one. We can say B is equal to F over I times L. Now, if I is equal to 1 amps, as we have mentioned before, if this is 1 amps and L means the length of the wire inside magnetic field, this is equal to 1 meter, and the force experienced by this wire will be 1 Newton. Then in this case, the magnitude of B means the magnetic flux density. This one will be equal to 1 T. This will be equal to 1 Tesla. And that's all what we need to understand to define Tesla. So let me explain you how you can write down your answer. One thing more you need to understand. Tesla is a unit. So you have to define this one in terms of units, means using units. This is how you can write down your answer. So in this case, you can see you have to mention that 1 meter, the unit length, current carrying wire of 1 ampere, experience a force of 1 Newton in a direction at right angles to both the flux and current. If you mention these points, you will get 2 marks for this question. Let's try to understand a little bit more about magnetic force, especially how we can write down this one in vector form. In vector form, we can say FB, this is equal to I times L cross B. In this case, L is also vector and L is called length vector. So this is a vector quantity now. We will be treating this one as a vector. And it has the same direction as direction of current. So simply we can say its direction is in direction of current. Very important point. In direction of current. And this order is also very important, because if you find L cross B using right hand rule, you can find direction of the force. So it has to be L cross B. You can now write on B cross L. If you do B cross L, direction of magnetic force will be wrong. Now if we expand this one, we can say this is equal to ILP sine of theta, and theta is the angle between L vector and is the angle between B vector. Current in fact is scalar, so theta is better to say this is the angle between L vector and B vector, not the angle between I and B. But magnitude of angle is the same, but this is a proper way to say theta is the angle between L and B vector. Now what is direction of L vector in this case? Current is up, so direction of L vector is also in direction of current. So this is also direction of L vector. So the angle between L vector and B vector in this case is theta. I hope this is clear to you how to write down magnetic force in vector form. And theta is the angle between L and B. For part B, it is given to us a stiff wire is used to form a frame, and dimensions of the frame are 8.0 by 6.0 centimeters. So one side of the frame is 8 centimeters and other side is 6 centimeters. And current in the frame is also given. Current is equal to 5.0 amps. It is also given to us that magnetic field lines are horizontal and the angle between magnetic field lines and PQ is 50, as you can see here. So the magnetic field is in the horizontal plane. Very important point. It is also given to us when side PQ first enters, means just enter the magnetic field, the reading on the Newton meter, means reading on Newton meter, changes by 1 millinewtons. Now we need to find out magnetic flux density B in Teslas, milliteslas. So first of all, we can simply write down what is given to us. Force is given to us. Force in this case is 1.0 millinewtons. I is given. I is equal to 5.0 amps. And L is also given to us. L means in the magnetic field, that is 6.0 centimeters. We can write down this one in meters. We can say this is 0.06 meters. We have to find out the value of B. Angle between L and B is given. Angle between L and B is given theta, and theta in this case is 50 degrees. So simply we need to find out B. So we can write down magnetic force is equal to BIL sine of theta. Sine of theta. We need to find out B. So we can rearrange this one. B is equal to F over IL sine of 50 degrees. So sine of 50 degrees. Force in this case we will just leave in millinewtons because our answer has to be in milli. So we can simply use this one 1.0. If you want to use in newtons, so we can also use in newtons. So this is how you can write down force in newtons. I is given. I is 5. L is given. That is 0.06 meters. So here we have sine of 50 degrees. Now if you do these calculations, our final answer in this case will be 4.4 times 10 to negative 3 Teslas. Simply we can say this will be equal to 4.4 milliteslas because our answer has to be in milli. So this is our final answer. And this question has 2 marks. The first mark you will get if you have written this formula. So this is the C mark. You will get this one. And the second mark is answer mark if you have got the right answer. So this is answer mark. This is how marks will be awarded. For second part, we need to state with a reason is the change in the reading on the Newton meter and increase or decrease. In first part, it was given to us that reading on Newton meter changes by 1 millinewton. Now question is asking us, is that change is an increase or is that change is a decrease? And that's what we need to find out. So first of all, we need to state and then we need to write down the reason for that. If we say increase, we have to state why increase. So we have to explain with reasoning how it increased. If we say it decreased, then also we need to give a reason for that. This is simply about Fleming-Lefton rule. So let's try to understand how we can use Fleming-Lefton rule for this question. For this question, it is given to us that PQ just enters the magnetic field. So this is side PQ. And the angle between PQ and B is given. Angle is 50 degrees. So I can simply also say this angle is 50 degrees. But we have to be very clear. B is in the horizontal plane. So B has 2 components. So B is in the horizontal plane. So it has 2 components. One component is along PQ. So this component has no effect. But one component is perpendicular to PQ. But this is in the horizontal plane. So it simply means that if I redraw PQ, so this is PQ. This side is P and this side is Q. Now it is simply inside a magnetic field that is into the page. So simply you can imagine that there is magnetic field that is into the page. And this wire is placed inside a magnetic field. That magnetic field is into the page. And question is asking us to find direction of force on this. So simply we can say B in this case is into the page. So this is external magnetic field. And I in this case, this is to the right. And we need to find out what is direction of magnetic force. So simply we have to use Fleming-Lefton rule. As you can see in this case, current is to the right. So this is direction of current and this is direction of magnetic field. Magnetic field is into the page. So direction of force, simply you have to use your left hand, but don't use the right hand. This is Fleming-Lefton rule. So the force will be upwards. So the force is upwards. It means reading will decrease. So simply we can say reading will decrease because the magnetic force is upwards, and magnetic force can be found using Fleming left-hand rule. Now let me show you the answer. This is how you can write down the answer. This is how you can write down the answer. If you have written this one, you will get 1 mark, and that is the mark. So you have to mention reading decreases, and you have to say force on wire is upwards using Fleming left-hand rule. So you will get 1 mark for this part. For the last part, it is given to us the frame is lowered further so that the vertical sides start to enter the magnetic field. We need to suggest what effect this will have on the frame. First of all, let's try to understand what does it mean by vertical sides. Vertical sides means this left side and this right side. Current in left side, this is down, current here is up, and current here, this is to the right. Now this frame is inside uniform magnetic field. I will explain you with the help of this loop inside uniform magnetic field, but you can imagine this one by yourself. You can visualize this one, but principle is the same. Now if you look at this magnetic field is to the right, and current on this side, this is down. So this current is down. As you can see here, current is down. But current on this side, this is up. Now if you look at these two sides, there is a force on this side. That force is actually out of the page. As you can see here, this force is out of the page, and force here, because direction of current is reverse, force on this side, this is into the page. So one force is out of the page, one force is into the page. So we can also use symbol here. This means into the page, and this force means out of the page. But if you look at the line of action of these two forces, are not along the same line. So it simply means that it will cause rotational effect. In this case, the loop will rotate counterclockwise, CCW, counterclockwise. But if you look at the forces acting on SP, means this side, SP, and forces acting on side QR, these forces are also acting in opposite directions. That if you look at the line of action of the forces is along the same line. So these two forces, they will not cause any rotational effect. So because the line of action of these two forces is along the same line. If you look at the resultant force acting on this loop, mean these four forces, the resultant force will be equal to 0. But the net torque is not equal to 0 because this force out of the page, this force into the page, they will cause rotational effect. And when side, I will just look at side PS. So this is our magnetic field. So when side PS, or we can say side SP, this will be perpendicular to the field. When this side will be perpendicular, you can imagine that when the angle, this angle is theta, when this angle will be 90 degrees, actually there will be no torque. So this is the second point you need to understand. First point you need to understand is that you can imagine when this will rotate counterclockwise. Finally, when angle between PS and magnetic field, this is 90 degrees, there will be no net torque because the force here, force is up, here force will be down, and these two forces also will be into the page and out of the page. But that line of action of forces when this angle is 90 degree also will be along the same line. So that time net torque also will be 0. But this loop will continue rotating because it has momentum. Net torque when angle is 90 degrees between SP and the magnetic field is 90 degrees. That time line of action of these two forces and line of action of these two forces will be along the same line. Means these two forces, they will cancel each other. So there will be no torque. And these two forces, one force will be into the page, one will be out of the page. So they will also be along the same line. So they will also cause no torque. So that time net torque will be 0. I hope it is clear to you. Main point you need to understand, when line of action of these two forces is not along the same line, there is a rotational effect. But when line of action of the forces is along the same line, means two opposite forces that they're acting along same line, they will cancel each other. And in that case, there will be no all. I hope it is clear to you. This question has only 1 mark. You can visualize this one later by yourself, but principle is the same. It has only 1 mark. So let me explain to you how you can write down the answer for this question. And this is how you can write down the answer. If you have written this much, you will get 1 mark. Simply, first thing, frame will rotate. Why frame will rotate? Because line of action of the forces is not along the same line. So there will be rotational effect. Welcome to A-Level and AP Physics. In today's lesson, we will discuss an important past paper question on nuclear physics from October-November 2021, Paper 4, Variant 1. In this question, we will discuss how to define radioactive decay constant, and also we will discuss how to calculate radioactive decay constant for any given sample. For part A, question is asking us to define radioactive decay constant. It simply means that question is asking us to define what is lambda. Let's try to understand in detail about lambda. We will start from radioactive decay law, or simply I can say we will start from decay law. According to decay law, dN by dt, this is directly proportional to n, means the number of nuclei in the sample. If there are greater number of nuclei in the sample, the rate of decay is faster. If there are less number of nuclei in the sample, the rate of decay is slower. We can also say that dN by dt, this is equal to lambda n. Lambda is constant of proportionality, or simply you can understand this is radioactive decay constant. We also use the negative sign in front of lambda. This negative sign, we need to understand what is the significance of this negative sign. This negative sign simply tells us that the number of nuclei in the sample decrease with time. It simply means that the number of undecayed nuclei, we can simply say number of undecayed nuclei in the sample decrease with time. Number of undecayed nuclei decrease with time. If you sketch a graph between n and t, the gradient of the graph, that will be negative. Let's try to write down this one in simpler form so you can have clear understanding. So first of all, we will replace dN by dt with delta n by delta t. They are representing the same thing. This is telling you delta n number of nuclei decay in time interval delta t. So this delta n is the number of decayed nuclei. So this is number of decayed nuclei. So we simply write down number of decayed nuclei. You have to be very clear. This is number of decayed nuclei. But n here it is representing number of undecayed nuclei. So this thing you need to understand. And delta t, simply this is time interval. So we can say this is time interval. So this is time interval. Now we can write down our formula in this form. We can say delta n by delta t. This is equal to negative lambda times n. Now if we write down lambda on left side, we can say lambda is equal to delta n by delta t divided by n, and the negative sign is here. So this is delta n by delta t. Now we can also rearrange this one in a little bit different form. This n we can bring here. So this is delta n by n, and this is divided by delta t. We have negative sign here. Now you need to understand what is delta n by n. So delta n is the number of nuclei decayed, and n is the total number of nuclei in the sample. So simply you can also understand this one in a simple language. Delta n is representing success, means the number of nuclei decayed. N is the sample size, so n is the sample size. So this is in fact probability. So simply this we can replace with probability. So lambda, I can simply say this is equal to probability of decay, because delta n by n is representing the probability of decay. So lambda is equal to probability of decay per time. So divided by time. So we have time here. So this is how we can define decay constant. I have already written here, so you can see probability of decay. If you write down this one, you get 1 mark, and this is a mark, means you must write down this. And the second mark is if you have written per unit time, you will get the second mark. So this question has 2 marks in total, and this is how you need to write down the final answer. For part B, mass of the sample is given, and mass of the sample is 5.87 times 10 to negative 10 kg, and activity of the sample is given, and this is in BQ. BQ is number of decays per second, and the unit for decay constant also has to be per second. So it means we no need to convert BQ into any other unit. Question is asking us to determine decay constant. So simply we can start from here, from very basic equation. A is equal to lambda n. In this case, we will not use negative sign because we just need to do calculations, so we no need to worry about negative sign. Now, if we rearrange this one, we can say lambda is equal to A over n. A is given, so activity is given here, so simply we can plug in here. But the problem is that we don't have number of nuclei. So the question is that how we can calculate number of nuclei. In order to calculate number of nuclei, you can first try by yourself. You can take some time how you will calculate number of nuclei, and then you can look at my solution, means my answer, how I will calculate number of nuclei. So take some time, pause the video, and do first by yourself. Now let me explain to you if you have tried this one. So number of nuclei simply you can calculate by dividing mass of sample, means the total mass of sample divided by the mass of single nucleus. So simply we can say mass of a nucleus, means mass of one nucleus. Let's say the mass of sample, this is equal to capital M, and the mass of nucleus is small m. Now again, problem is that how we can find the mass of nucleus. So let me explain you first of all with one simple example. Let's say we have carbon 12. How we can find the mass of carbon 12? The mass of carbon 12 will be equal to its mass number times U, means it will be equal to 12U. So simply we can say it is equal to the mass number, or you can say this is equal to nucleon number multiplied by U. So this is the nucleon number. So I'm writing here the mass of nucleus. This is nucleon number times U. So this is M. So we can write down here. This is the mass of the sample. You have to divide this one by nucleon number, and you have to multiply this one with U. Means simply mass number times U. So nucleon number times U. And this one now we can use here. So we can say this is the activity divided by this one. So this is divided by mass of the sample divided by nucleon number. So here we have nucleon number times U. So nucleon number times U. We can rearrange this now, and we can write down this will be A times nucleon number. So here we have A times nucleon number. So this is nucleon number times U. So this is U. This is divided by mass of the sample. Now activity of the sample is given. So simply we can write down activity of the sample, that is 2.92 times 10 to 9. This is activity of the sample. And the nucleon number of this nucleus is given, that is 131, and U is 1 AMU. And 1 AMU is simply equal to 1.66 times 10 to negative 27. You can also find this one in data. This is given in your paper. So simply we can write down 1U is equal to 1.66 times 10 to negative 7 kgs divided by the mass of the sample. Mass of the sample is 5.87 times 10 to negative 10. And if we solve this one, value of lambda will be 1.08 times 10 to 6 per second. So this is our final answer, 1.08 times 10 to negative 6 per second. And this is our final answer. This question has 3 marks. First mark you will get if you have written this formula. You will get the first mark. And the second mark you will get if you have written the mass of the nucleus, means mass of one nucleus. This is equal to this, means nuclear number times U. So if you have used this one, you will get second mark, and the second is also the same mark. So if you have mentioned this, you will get the second mark. So simply, and actually the C mark will be for this one. The second C mark is for this. If you have figured out how to calculate the number of nuclei, you will get the second mark. So this is the second mark. And the last mark is for the answer mark. If you have got the right answer, you will get third mark. So this is how marks will be distributed. For part C, question is asking us to suggest 2 reasons why a detector placed near to the sample in B record a count rate much less than 2.92 times 10 to 9 counts per second. Actually, this is activity of the sample that is given in part B. So we have to explain that why the recorded count rate. So simply we can say why recorded count rate by detector, this is much less than actual count rate, means the activity of the sample. So simply you can understand actual count rate means the activity of the sample. So this is actual count rate. We need to explain why this is less than. So imagine that we have a detector first of all. So let's say this is detector. We place one detector here. So this is detector. So this is detector, and we place one sample here. So imagine that this is sample, radioactive substance sample. So this radioactive substance, this will emit radiations in all directions. So when it will emit radiations, they will go in all directions. So they will not go in one direction. So this detector, it will only detect radiations reaching this one. So this is one reason. So we can say radioactive sample emit radiations in all directions. But this detector will only detect radiations reaching the detector. So that's reason the activity of this one will be much greater than the count rate detected by this detector. So this is one reason. And the second reason we can say, as these radiations, they travel from here to the detector, there is a gap between these two. So some of radiations will be absorbed by air. So that's reason count rate will be less than activity. And some radiations also will be absorbed by the window of the detector. So this also will cause decrease in count rate. We can also say that detector is not efficient enough, means detector cannot detect all the radiations reaching this detector, or we can say this detector has dead time. So about detector, you can also mention, you can say detector has dead time. So one thing you can say detector has dead time, or you can say detector is not efficient enough. So you can say detector is inefficient. So you have to write just 2 points. So you can say sample emit radiations in all directions. So all the radiations cannot reach detector. So you will get 1 mark. And the second mark, you can say that some of the radiation they are absorbed by air, because between detector and sample is air. And air can absorb alpha radiation. So some radiations will be absorbed. And you can also say that some radiations maybe they are absorbed by the window of the detector. So if you write down these points, you will get 2 marks. Even you can also mention about dead time of counter, means the dead time of detector. So let me show you how you can write down your answer in a proper way. So this is how you can write down your answer. I have mentioned these points. If you have written these points or you have understanding of these points, you will get 2 marks. Only you need to mention 2 points. So you can mention this 1 point, you can mention this one, this is the second point. But here you can see there are 4 points. Self-absorption within the source, this also can be the cause of less count rate. You can say dead time or inefficient detector. So if you write down any 2 points, you will get 2 marks. So first 2 points are very easy to understand, so you can focus on first 2.